Well, hello there. Welcome to my channel. In today's presentation, I'm going to show you how to measure the solar irradiance from a solar panel and taking that information and recreating an equation to use a secondary solar panel as a portable radiometer for measuring the sun power. Okay, let's get some background information. Panel A is a 100-watt Windy Nation solar panel. I'm measuring the short circuit current. I'm using the 10 amp input on my multimeter, and I have the selectors switched to the 10 amp terminal. All right, I'm measuring 430 milliamps or 0.4 amps. On the back panel, panel A, I have an STC current of 5.94 amps when I'm flashing 1,000 watts per meter squared onto that panel. Excuse me. Panel B is a 1.5 watt Harbor Freight trickle charger for a battery, 12 volt battery. I've swapped my probes to the Harbor Freight panel, and I'm measuring 5.3 milliamps on that. There is no label on the back of this little panel that tells me what my STC ratings are. STC is standard test conditions. All right, so we've done the measurements. So let's look at panel A first. The solar irradiance striking panel A, I'm going to label it G, is the measured short circuit current, the 0.43 amps, divided by the STC short circuit current times the STC test condition of 1,000 watts per meter squared. So plugging the numbers into the equation, 0.43 divided by 5.94 times 1,000, this solar panel is seeing 72.4 watts per meter squared. And taking that information, I'm going to use that as my reference power for my new equation for the little panel B, the Harbor Freight. And I'm going to use the 5.3 milliamps as my reference current instead of using ISC. So anytime I measure this panel, I put that measurement here as the measured value, divide it by 0.0053, which is 5.3 milliamps, times 72.4 watts per meter squared. And that gives me a portable radiometer. I can go around and I can measure the sun intensity, sun power, solar irradiance, solar radiation, whatever you want to call it, anywhere I want. And it's easy to carry, and all I need is 1 meter. Notice I've changed the probe input to the milliamp range and changed the selector switch. Okay. The short circuit ISC stands for short circuit current, and STC stands for standard test conditions of 1,000 watts per meter squared, 25 degrees C, and an atmospheric thickness of 1.5. And that's a standard test condition to compare one solar panel to another solar panel without environmental effects such as clouds and so on and so forth. Okay. An important note to make, the short circuit current of a solar panel is relatively immune to temperature effects. It has a temperature coefficient of 0.06%, so I've ignored it. It's not, with my quality of meters and quality of test here, it's not worth worrying about. But this should give me a good way to measure. I want to mount this somewhere where I get a lot of sun. And I can walk around my yard and see where I can get the best sun for most of the day with just this little device. All right, that basically covers it. Kind of interesting that calibrating a small panel to a big panel, and a big panel has been calibrated to the standard test conditions. So y'all have a wonderful day, and hope to see you in the future. Bye-bye. Oh, how do I turn this off? There.